Roofing University with Adam and Mason.
Welcome to another episode of Metal Roofing University. I'm your host, Adam Clark, and as always, I've got Mason Burchett with me.
How's it going?
And in our last episode, Mason, we were talking about the quality of the steel, the substrate, the paint. We kind of covered materials and why Best Buy Metals has decided to move forward with only the top quality materials when it comes to presenting a finished product to our customers. But we touched on the equipment side of quality control and quality maintenance in that episode, but we didn't really do a deep dive. So I thought today might make sense to go ahead and expand on that a little bit.
Yeah, for sure. So like you said, we touched on it. There's a whole other side to the quality conversation when it comes to metal roofing products. A lot of people are focused on the paint and the steel, and which is all very important. That's why we just did a whole episode on it. But as you can see behind us, there are a lot of high-quality, heavy-duty machines that come into play when you're manufacturing metal roofing products. And the quality of those machines, the way they manufacture the materials, dictates the quality of the material as an end result. So, Adam, let's start off the conversation. Maybe you just kind of defining what some of those processes are. Like, what is roll forming? What are some of those processes?
Yeah, sure. So most people know what a finished panel looks like, a roll-formed panel. If you go and you look at a metal roof anywhere on a residence or a commercial structure, it's a pattern roof panel. It's the same, it's consistent throughout the entire roof. But what we start with is going to be a flat coil, typically a 10,000 pound coil. Most of what we work with is 29 and 26 gauge, and usually they're about 41 to 43 inches of just flat sheet metal. And so what we do is we take the sheet metal and we move it through our roll formers. And a roll former is essentially a series of dies or a series of forming dies that run in sequence to go from taking a sheet of flat metal to the formed product.
Yeah. So, and if you're listening to the audio version of this podcast, I'll encourage you to hop on YouTube and watch the video of this, because we're playing some B-roll as Adam's talking, showing what those processes are. So you might get a better picture of it as he's defining that.
Yeah, and with the roll formers, it's really, it's kind of cool because we do have the ability to make a number of different profiles. And while there are some industry standards or some industry defaults like our tough rib or the PBR panel that we work with, we've also had the ability to customize some panel profiles that are specific to Best Buy Metals. We actually have a formed tile panel. We're the only ones who really carry the specific type of formed tile, and it's a roll former plus a hydraulic stamp that actually presses out the tile, which is pretty cool. And then we've got some standing seam machines that are a little bit different than these larger, 45, 50 foot long roll formers. They're actually portable formers that we're able to take flat coils out to a job site, run the coils through these formers, and actually produce the panel there on site. And the panels are quite a bit different. They're much more narrow. There are much fewer bends, so we don't have to have the same number of passes or the same number of die sets to produce that profile without causing undue stress to the actual panels that are going through, the metal that's going through.
So your panels are the primary material covering the vast majority of your roof surface area. Roll formers are what is making those panels, right? So we've talked about it. Roll forming is essentially taking that flat piece of steel and sending it through a series of dies or rollers that are crinkling that flat piece of steel essentially, and then it comes out as a finished product. Seems pretty straightforward.
Yeah.
What could go wrong in the roll forming process? Can anybody do this?
Yeah.
Is every roll form panel the same?
Yeah, probably everybody can do it, but the finished result's always going to be a little bit different. So if we're just talking about the quality of the machine, and that's kind of what we're focusing on now, there's a few things that we're really going to want to be intentional to talk about. One is, of course, the number of passes. On 3 foot wide panels like the tough rib panel or the R panel, PBR panel, we have 16 sets or 16 passes of dies that the flat sheet needs to go through before it reaches its final formed phase. And the reason that we have 16 passes is because each pass is designed to add a part of that profile. Now, there are some machines out there that have 8, 10, 12 passes that produce the same profile, but the problem that you have with those machines that have less passes on them is they introduce more bends or harder bends, like steeper or sharper bends to the flat sheet as it goes through, introducing way more stress on the paint, the substrate, and the steel.
Okay, so what are some of the consequences of roll forming this flat steel in a machine that has less passes or less sets of dies than our machines do?
Probably the main thing would be the stress that's on the metal. If you have paint that begins to crack, or even metal that begins to break at the seam, which we've seen before on a really sharp bend on, say, a grade 80 steel or a harder type of steel that's going through the machine, you could actually have pieces of metal that are breaking. If you think of taking a piece of steel angle or something where you bend it over itself and kind of hem it across itself, and it just snaps along that line. Or like aluminum, you see people who take aluminum, they'll bend it back and forth a couple of times and it starts to actually just break at that seam. Well, that's what you'll get if you have too much pressure on the flat sheet going into too few passes. The other thing that you're really risking is consistency. You're going to have these really extreme bends and a lot of pressure on the flat sheets that are going through. And so you're going to have bends that are affected differently based off of the hardness. And when we're talking about the hardness, we're talking about the KPI, or the kilopounds per square inch. We're really talking about the hardness. I don't really know how I don't know what other word makes
the hardness.
Sense. The hardness of the metal, and basically what that's saying is it has a minimum KPI of 80 pounds or 80 kilopounds per square inch. Now, because that's a minimum level, it certainly means it can be higher than that as well. So steel is not always perfectly consistent. It all depends on how it's heated, and we've been to the or I've been to, I don't know if you've been, but I've been to the mills, and you see the furnaces and you see the consistency of how they're actually heating the metal to get hardness, and it's a great process, but it still has imperfections to it, which is why there's a minimum KPI. I keep saying KPI, it's KSI.
Key performance indicators
per square inch, KSI. So what we're talking about is one part of the coil might come through, or one coil might come through at 80 KSI. The next one might come through at 100. And so you're getting different pressures on different hardness of metal. So the fewer dies you have, the more likely you are to have a different profile that comes in or comes out at the end of the machine.
Okay, and so even I would assume, and I know the answer to this, but I'm going to be rhetorical here. I would assume that even if you don't have a scenario in these roll formers with less passes where you can visibly see steel breaking, thinking back to the episode we did on substrates, the galvalume substrate in the paint like we've been talking about, that can put more, tension or stress on that substrate and on the paint. Is that right, even if it's not visible?
Yeah, absolutely. And it's very visible with the paint, again, and we've seen this before on some materials that we've gone out to inspect for our customers, and it's typically the paint that's flaking off at these bends. It's just too much pressure. And the baked on paint finishes that we use, the Sherwin-Williams paint systems that we use, and the way that it's been coated, it's designed to bend and move with the metal as it goes through the former. But there are limitations to that. And if you're bending too far, too fast, or too hard, paint will actually start to lose its adhesion to the substrate and to the primers. And you're going to have a panel coming out with paint already flaking off. And then you have to start to think, well, if the paint is already flaking off, right when it comes out of the machine, what's going to happen when it's exposed to the elements? What's going to happen when it's exposed to the sun? And breakdown begins to happen almost immediately after it leaves the machine. That's the last thing you want on a roof system that's supposed to last you a lifetime.
So essentially what we've described here is you can have two panicles. Wow. Words are hard. You can have two panels that look identical and they be very different by the way that they were manufactured. You can have one that was sent through an appropriate number of passes and one that was not, and they'll perform differently.
That's right. Yeah, and you might have the technical sheets or the specs from each machine be identical. The end product is supposed to look the same, but you may also have a machine that is not spitting out the profile that it's supposed to.
Sure.
And that's something that we see too. And we talk about consistency. You also see machines that where the metal is experiencing too much stress. We have to keep in mind the dies are also experiencing more stress when you have less passes, and each bend has to be a little more extreme. So you start to see breakdown of the dies pretty quickly as well. And then you start to see waviness. If you're looking up the panel, you should see just a straight line, but you may start to see waviness, whether the dies are they're starting to break down or wear down. And most people don't think about this, but you run 100 million feet through a set of dies, they're actually going to start becoming smaller in diameter. They're going to start wearing down. And that happens more quickly on machines that have less dies. Again, and the less dies you have, the more impact, the more pressure you have where the flat sheets go through. So the hardness of the dies is also something that's important. And that's something that a lot of people don't know, but we actually pay for harder dies. And we do that because we want our machines to last as long as possible. We want the profile of our panels to be as crisp and consistent as long as possible. There's a process that these dies have to go through, a heating process they have to go through to achieve this hardness. And you can pay for dies that are not as hard, and they'll break down more quickly. And typically that's what you see on a cheaper machine: less passes, less dies, typically softer dies that begin to break down more quickly.
And as those dies break down, you'll see a less defined profile that's coming out on the finished panel. Is that right? You'll
see a less defined profile. So the little pencil ribs or the ribs on top of the major ribs will begin to disappear. The minor ribs can even start to disappear. And basically your profile begins to change. Sometimes it begins to elongate, where you're supposed to have 36 inches of coverage. Well, if you're not getting the forming profile that you're supposed to have, and some of the bends are losing their sharpness, you'll actually have that panel start to stretch out, and it will become wider than 36 inches. Some people think, well, that sounds like a good thing, but you begin to lose the height of your panel ribs, which affects the minimum slope it's designed to be applied to. You also get inconsistency of the product. So if you're doing a multiple phase project where maybe you're doing a primary roof at one point in time, and then 3 months later you're coming back and you're doing like a wraparound porch, well, your panel ribs begin to space differently, and you're not able to line everything up and have a consistent line pattern or rib pattern. So that becomes a problem as well when you're dealing with an inferior machine, especially with dies that are breaking down more quickly than they should.
And all of the bends and the contours of your panel, and let's take the tough rib panel or ag panel as it's often called as an example, those aren't just for aesthetics. They actually serve a purpose. So for example, if you look at a properly installed tough rib roof where panels overlap, you'll see a little bit of a notch that runs the entire length of the panel. That's called an anti-siphon groove. And it actually serves an extremely important purpose. Why don't you talk about what purpose that serves and what happens when that's eliminated by a bad panel profile?
Sure, yeah. Another thing that a lot of people don't think about is water accumulation on the roof. When you have a heavy rainfall, even though gravity is pulling water off of that structure, off of that roof, you still have a tendency for water to accumulate up to a certain point, which is why we have recommended minimum slopes for our panels. Basically, with the tough rib or the ag panel, we say a minimum pitch of 2.5, 12 slope. So that's 2.5 inches over 12 inches, 2.5 inches of rise or fall over a 12-inch run. And so essentially what we're saying is, even in the heaviest downpour, we feel confident that there's enough gravity pulling on the rain or the water that's accumulating on the roof that it won't get beyond the height of that panel rib, which is 3/4 of an inch. The anti-siphon groove helps push water down that overlap of the panel. So, you don't really have any exposure in the middle of the panel because everything is continuous, but where the two panels, where adjacent panels come together, there's an overlap, and we want to make sure that if water does begin to accumulate on the roof, it hits that anti-siphon groove and it shoots that water down, almost like a gutter system for the panels. Now, if you start to lose the definition of that groove, you might have water that begins to go up and over the lap without any interference from that curved groove, and that's going to create leaking problems even if your roof meets the minimum slope requirements of the panel.
And this is all stuff that people that aren't educated on this, which is why we're doing this, might not be able to detect And you can easily get sold a panel that seems to be identical to something quality that's going to perform drastically different. So moving on to that in that manufacturing process, Adam, there's another portion of this beyond just roll forming the material, and that's actually cutting the material. Yeah. There's a couple different ways that the material is cut to length. Why don't you speak to that?
Yeah, and there's not necessarily a right and wrong when it comes to post-shear versus pre-shear. And pre-shear is when you're actually cutting the flat sheet that's going into the machine versus post-shear, which is where you're cutting the panel after it's been formed. For us, on our high volume lines, we believe that the pre-shear option gives us a better machined edge. We do have some standing seam profiles which require typically shorter panels, or the option to cut shorter panels, and that does require a post-shear option. So there's not necessarily one that is right or wrong. It really depends on application. But what we have found is on our primary line, our tough rib and our PBR line, that the pre-shear gives a much cleaner, much more consistent edge. And it also is going to help eliminate any of the, or minimize the exposed steel of the panel, cutting down on the rust edge and the rust creep like we talked about in the last episode. So for us, we prefer the pre-shear on our high volume lines. We think it's a better option. Again, the post-shear is used when you need to have a little more versatility in your panel lengths. For instance, on our tough rib machine, our passes are about 2.5 feet apart from each other. So if I try to run a pre-sheared piece of metal, a flat sheet, through that machine that's 2 feet long, it will fall down between the passes, right? So that doesn't work. So we can't run anything shorter than that. For our standing seam machines, we often have accents, on parapet walls or different entryway accents where the panels might need to be 18 inches. If you think over a garage, sometimes you have that little accented ledge that goes around like in front of a gable, but over a garage door. Those are oftentimes shorter. We need to find a way, or we need to have a way to make those shorter panels. So my recommendation is on an ag panel, a tough rib panel, a PBR panel, the pre-shear is always going to give you a better finish. It is going to give you a better finish. For standing seam, your hands may be a little bit more tied as far as what you can do for a pre-shear, so that's why we approach the post-shear. But we think that, again, we've got a great post-shear system and assembly that is really consistent, and we work with machine suppliers that help allow us to get the best machined edge on a post-shear panel that we can get. But it is always going to be a little bit compromised, because you have to think about it. You're shearing down on an arch, a formed panel. You've got a rib or an arch in that metal, and you have to come down, and it makes sense that it's more challenging to get a clean shear on something that has the ability to give down, as opposed to a flat sheet which has consistent downward and upward pressure. We're using a shear that doesn't have to fight with any bowing or springing of a panel.
And we also assume proper installation when we select machines that are post-shear versus pre-shear, because like you're saying, on these standing seam panels where it's post-shear, that edge, that post-shear edge, if installed correctly, is typically not exposed or visible. It's hemmed around an extended eve drip edge, which eliminates that concern. Your ag panel and your PBR panel, just the design of those panels, they're not hemmed around an extended eve like that. They're always left exposed. So that pre-shear is a better option for panels of that nature. And that shear, if you're watching the video, watching this, you can see it there. It's kind of a scissor cut. So it helps close that substrate together, like you were talking about in the last episode.
Yeah, it's tapered. So if we go and we measure the height on our shear, one side to the other, one side's about 1.5 inches higher than the other. So it's actually cutting just like a pair of scissors would, where you've got one end that's starting and it goes in sequence to the other side, making that a nice, clean, kind of a crimped edge as it seals around and kind of pulls the substrate and the paint around that steel. That's pretty important for sure.
So we've talked about roll forming panels, which is what a lot of people that are familiar with the metal roofing industry think of when they think of roll forming. But at Best Buy Metals, we actually have a whole nother line of roll formers, and that's our trim roll formers. Talk about it a little bit.
Yeah, it's very similar to our primary tough rib and R panel rollers. This actually is provided by the same manufacturer because we like the consistency of the products that we get from them. But it's a set of passes, or a machine that has a set of passes where we push a flat sheet through. That's a designated width, 13 5/8 or 9.5 inches, and it goes through a series of passes. Again, we're not doing this all in one pass. We don't have a set of dies that's the profile of our ridge cap,
right,
and we just push it through and it kind of forms everything at once. It goes through a series of about 12 passes that creates a consistent profile, like our ridge cap and our gable trim. They're the two highest volume parts that we have. We want them to be the same every single time, right? We don't necessarily want them to be made on a brake, although we'll talk about brakes here in a little bit, but we want to be able to just push a flat sheet through and get the same piece again and again and again and again, because that's what our customers have come to expect from us. We also have the ability to make different lengths when it comes to that. Some people have limitations on their brake size. Like if you have a 10-foot long brake, then you can only make 10-foot wide pieces.
Or a 20-foot, you can only make 20 foot.
Right, yeah, we have limitations here even with our 20-foot brake. So what we can do is, we have the ability with our trim roll formers, I'm pointing to them over there for anyone who is watching the video, that we're able to run whatever. I mean, we could technically run a 50-foot ridge cap through there. We're not promoting that. That's not what I want to do.
We're not going to deliver that.
But we could, and that's we have a lot of people who like 12, 14, 16, 18-foot pieces of the primary, ridge cap and gable pieces. So we make those, and that's a service that we're able to offer for a customer. You're limited by not having these machines. The other benefit that you get, apart from consistency and longer lengths, is volume. On most of our brakes, this one behind us is a little bit different, but on most of our brakes, we're making maybe 300 or 400 pieces of trim on that brake per day. On our trim roll formers, we should be able to make about 700 pieces per hour, of these primary parts. So we would not be able to offer the quality of service and lead time that we have if we didn't have trim roll formers. And that's something that you'll run into for other operations or other suppliers. If they're experiencing a really busy season, like we've been in, it seems like for months now, lead time might be pushed out simply because the brake is a bottleneck. It can be a bottleneck when volume picks up. The trim roll former really helps combat that. Okay,
so you've talked about that, and that leads us into the trim conversation. There's a system with the brake where we manufacture custom trim or stock trim, but we make it in a different way than roll formers do. So this is made a completely different way. There are different kinds of brakes that can affect the quality of the material, the way that it bends the material.
Yep.
Is that right?
Yeah, and I think that's the thing. That's why we wanted to do this episode, because the number of variations that you can have from machine suppliers to really even just the characteristics of the equipment is just so broad. What we work with is a teardrop lip on our brake, and what that allows us to do is it allows us to make more of a rounded hem, or what we call a teardrop hem, as opposed to a sharp edge or a sharp hem, which can, much like a roll former that doesn't have enough passes, can add too much pressure to the bend or too much stress to the bend and cause that metal to crease and to crack and break even. So our teardrop lips on our brakes allow us to make a bend or make a hem that we know is not going to fail, and it's not going to challenge the paint or the integrity of the paint along that edge, which is one of the most important parts, because when you're making a piece of trim, if you don't have a hem on it, you're typically putting it on top of sharp metal on top of the ribs of your panels, which is going to cause those to break down. So that may be something that we can talk about even in future episodes when it comes to application. But we really believe that anytime you have a piece of trim on top of a metal panel, there should be a hem that prevents the sharp edge of that piece from scratching and rubbing against the panel. So having a machine that makes a quality hem that's not going to challenge the integrity of the metal is going to be really important. The other thing is making sure you can have consistency. We work with actually a couple of different providers for our brakes, and one of the things that we really value is being able to program with a computer, being able to program a profile in and make the same piece again and again and again with great consistency. Again, it's not maybe as fast as the trim roll formers, and we understand that there are some limitations to how much volume we can produce on our brake, but the value of having a good brake and having good software and having good attachments is that you can actually go in and you can make a lot of things that you obviously can't make on a trim roll former.
Sure.
Your profiles are set on the trim roll former, but on a brake, you have great versatility. We've actually rolled out some new profiles, and it's been because of this machine.
Yep.
You want to talk a little bit about some of those?
Yeah, so that was the next avenue I was going to go down. Like you said, with trim, your trim roll formers are set to a certain amount of profiles, because you can't change it. Obviously, they're set dies. The brake allows you to make a number of different profiles. That's the same with our panel roll formers. They can't make custom profiles. They make the profile that they're designed to make, and that's great. It provides great consistency, over time. The quality of our brake here, and using that teardrop lip or nose or whatever you want to call it, allows for that same consistency. A little longer to manufacture, takes a little bit longer to manufacture, but it allows that same consistency, not just in trim, but in people that want custom panel profiles as well. So this machine that you see behind us is called a Vario bend. It's a 20-foot brake, and it's awesome, and it lights up, and we like that. Yeah. But it allows us to create unique panel profiles, roofing panel profiles, soffit, wall panel profiles. Essentially, somebody can come in and scribble down something they've imagined, and we can likely make something like it or something close for them. And Adam, because we've chosen to go with quality machines, not only can we make it, we can make it as a quality piece in large volumes consistently.
Yeah. Yeah, and we've one of the reasons that we really like the Vario bend is the speed at which it operates. There are other brakes out there that are still great, but they just move about a third of the speed as the Vario bend. So we're in a season of high volume. We're in a season where we need to have a machine that can do the number of pieces per day that our customers demand for the lead time, the same day and next day service that we offer to our customers. So that's why we went with this machine. And yeah, being able to have an upper and lower variable arm, so it doesn't just bend in one direction, it bends from the top down and from the bottom up, has allowed us to increase our output on a number of normal pieces that we've always offered, but it's also allowed us to introduce some wall panels, and we're seeing a huge trend, a lot of movement to steel siding. That's something that we're excited about. The vinyl world is a little bit weird. It's really been saturated by a lot of different supplies, and there's been quality issues, and there's also been some issues with shipping cost as that's increased. So we've decided to be a little proactive to that, and we've started to make some horizontal, even some Dutch lap siding. We're making board and batten siding, an alternative option to vinyl, which has either become increasingly hard to get, higher in cost, or less reliable from a quality and consistency standpoint.
Yeah, and a machine like this is able to do things that other machines can't offer. Things like flush mount wall panels with that seamless, aesthetically pleasing look that you see on a lot of architecturally designed buildings, or soffit panels with the tongue and groove kind of system where the fasteners are completely concealed and you don't see a lot of rigidity. Everything looks flat and smooth. That's another thing that this kind of machine allows us to do that other machines aren't really able to do.
And we see a lot of people, especially for interior application, for walls and for ceilings, really liking that flush panel or the soffit panel. And they like it because it's concealed fasteners, so you don't see any of the fasteners. It butts up seam to seam, so there's no gaps. It's really just, you can see the seam, but it's butted up, it's flush, and it's steel.
Yeah.
So instead of going and putting corrugated panels on a wall, which we see a lot of people still do, and we sell the corrugated panels, and we're happy to obviously keep offering that because that has its own unique look. But we're seeing a lot of people who kind of like that industrial finish down in their basement or down in their workshop or in their home offices now. People who are looking for a cool way, because a lot of people don't realize this, but get whiteboard and batten or soffit panels, put them down in an office space, and use an expo marker on there. You've got a whole wall that's a whiteboard, and that's kind of a cool concept that people haven't really considered before, and we're able to offer that option as thinking outside the box, and that's been kind of cool to be able to talk to people who are excited about that.
So the last thing I want you to talk about just for a second, and we'll wrap this up, is in the cutting process. In regard to trim, there's really two different ways that you can shear materials. We've done it and do it both ways, but we've made a move towards a slitter machine that can slit in large volumes, and it cuts the material differently than, say, the Smart Cut shear that we've got over there.
Yeah, so the two types of cutting is going to be a shear process, which you put a flat sheet in, you adjust the throat or the depth of that shear to whatever depth you need, and you hit a pedal and it shears that piece off. It's pretty labor intensive. It works fine. I mean, you can get the size that you need, but it's pretty labor intensive. So about 18 months ago at our Cleveland office, we invested in a slit line, and we actually just installed a new slit line in our Greenville, South Carolina facility just a couple weeks ago. But the way that works is the slit line works by putting a coil on a decoiler, just like we would with our roll forming machines. And there's a set of slit wheels that are going to be in this machine. So we'll go in and, the strategy is to put a green coil on and run every green piece of trim, the flat that we need for that coil color. So we'll enter all of the different quantities and drop widths or flat widths that we need. The machine is smart. It's all computerized, all automated. So as soon as we hit go, it starts moving those slit wheels around and it starts processing those. So really our operator could set it, leave, come back to a full table of all the cuts that we need, and then we wheel it over to the brake and they go ahead and they start manufacturing that. How much faster is it than the hand shear? It's quite a bit faster.
Sure.
I'm even like trying to, calculate. It's probably 1,000 times faster. I mean, the reality is like, the brake used to be a bottleneck for a couple of reasons. One, because the brake is a little bit slower just by the way that it has to move. And two, because shearing flats and getting drops to the brake was time consuming as well. Well, now if we look around, and you guys can't see them, but I can. We've got tables full of drops that are ready to go through the brake. I mean, we're just able to run the volume that we need to run now because we've been able to make this investment.
And I'll speak to this because back in the day I've operated this manual shear machine, and even the slitter where you manually move the wheels yourself. The slit line that you're talking about we've invested in provides not just volume, the ability to make larger volume, but it's more consistent. It eliminates a large margin of error that an operator can make. I know that because I've made those errors where you set the measurement to the wrong thing just because you're working all day and you're flying, you're trying to get it done. You set it to the wrong thing, you have something off by a half inch and you lose a hem. This eliminates that.
That's right. And I'll speak to one more thing as well. Machines are really important, and hopefully we've been able to highlight the fact that quality machines are going to be what really helps determine quality machines, along with quality materials, is going to determine the quality of the finished part. But your quality control processes really are going to be the thing. I mean, anybody can buy one of these pieces of equipment, but your preventative maintenance, your daily inspections. So for us, we do this at all of our facilities. At the start of each day, we check the squareness of all the flats. Even with the Smart Shear, even with the shear that we have, our standard operating procedure is to come in and to make 3 shear cuts and then measure the left and the right side of that last piece that's left on the machine to make sure that we're not cutting anything out of square. And if it is, then we recalibrate the machine. Same with our roll formers. What we do is we try to make sure every morning we come in, we have a template panel. So it's a panel that was taken off the machine right when we got the machine, very first panel that came off, because we're assuming that when we got it from the machine provider, they gave us a machine that was in spec. They checked it at their shop. So we've got all these template panels that we actually use each morning to make sure that the width of our ribs, the consistency of our panels is matching what it was from the day we had originally got the machine. So having these processes in place ensures that we're not going to be running into issues even with quality machines. And that's something that you have to be mindful of. If you're dealing with a company that seems scattered and disorganized, even from the sales process, well, ask yourself, is that a reflection of how they treat their manufacturing? Because if they're not organized, if they're not systematic, if they don't have a plan with what you do see, odds are they're not going to have those plans with what you don't see. And a lot of production is done behind the scenes. We don't typically have people in our warehouse with us rolling panels out. But I think if somebody went into our sales ops and they saw, hey, Step one, greet the customer. Be kind and be courteous. Listen to what the customer's real needs are. Promote a solution to their needs.
There's a system in place.
Absolutely. And if they can see that system, they can have confidence in the systems that they do see. We obviously want to make sure that we're being accountable to them to have this processes in place for the things that they can't see, especially when it comes to quality products.
So, guys, to recap, and we'll wrap this up. To recap, essentially what we're saying is, last episode we talked all about materials and quality of materials. You can have excellent quality materials. You can have the right steel sourced from the right place with the right substrate and the right coating, sourced domestically. You can have all that and everything be nice and quality in the way it's supposed to be. And then you can run that quality steel through bad inferior machines and get an inferior product. So you have to, likewise, you can have bad materials run it through a good machine and still have a bad product. Right. So you have to have both. You can't pick one or the other. You have to marry that quality material with quality manufacturing machines and processes, like you just said, to get a metal roofing system that truly will last you a lifetime. Yeah.
Just like a sports car,
That's right.
It might be expensive. You might run great. If you don't maintain it or if you don't use it the way that it's supposed to be used, you're not going to have the experience that you thought you're paying for. And we think the same thing here with our equipment. So, Mason, I think that's going to wrap it up for today.
Yeah, so we appreciate you guys tuning in for another episode. If you liked what you heard, consider subscribing. And again, if you're listening on the audio version, through Spotify or Apple Podcasts, check out the YouTube video because we did have a lot of cool footage of the manufacturing processes we were talking about. It'll really help tie everything together, allow you to visualize it and see what we were talking about. If you want more information, you can go to metalroofingu.com to see some of the stuff we're talking about here on the podcast. If you want to see some of the products that these machines manufacture, go to bestbuymetals.com, our website, and you can explore all of those products there. Until next time, thanks, guys.